So use algebra to solve. And I notice it's quadratic. So first of all, I can move everything, quadratic equations we solve by making one side equal to 0. So I move everything over to the left-hand side. And we want to solve. It's quadratic, so either we have to factor or use the quadratic formula. If you were trying to factor it, I like factoring because factoring is usually quicker. We're going to run into a problem. I'm sorry, foreshadowing problem coming, but I'm going to try to factor it. That's my first one, and that's my last one. This, if it could be factored, more foreshadowing. If it could be factored, there's only one option for the first one. It has to be 3 cosecs and cosecs. And my last one's a 1. There's only one option for that. It has to be a 1 and a 1. If this was factorable, this is the easiest one. We've had no options. All we have to decide is positives and negatives. And I need my outside and my inside to make 1. Can you see my outside is 3? My inside is 1. 3 plus 1 is 4. 3 minus 1 is 2. I need a 1. So I tried to factor it only to find out it is not factorable. So then I have to go to the quadratic formula. Right? When you get really good at factoring, how fast could you tell that it was not factorable? So we go to our quadratic formula. It would be cos x equals negative b, the b value is a 1, plus or minus b squared, 1 squared is 1, minus 4 times a, which is 3, times c, which is a negative 1, over 2 times a. Simplifying this, negative 1 plus or minus 1 plus 12 is the square root of 13 over 6, which gives us 2 possibilities, one with the plus sign, and one with the subtraction sign. Arrow, possibility 1, possibility 2, split them up. Sometimes you can tell right away if things are positive or negative, like mental math. I have all negative numbers on the top of this fraction. I know this side is going to be negative. But sometimes it's nice to type it into your calculator just to check. So I would have negative 1 plus the square root of 13 divided by 6, 0.434. So I can see this one is positive. This is going to be in quadrant 1 and 4. This side, I know it's negative, but I'm going to check it with my calculator as well. Subtract. Enter. Negative 0.767. The other thing I like to do with checking these is if any of these answers was bigger than 1 or less than a negative 1, then it could be non-calculator that you could go not possible right away. Again, when they're fractions with square roots, like, was your gut feeling this was going to be 0 point something? Or did you have no gut whatsoever feeling on that? Probably no gut feeling whatsoever. Like, I have no idea what that number would be as a decimal. So now that we have these, now it becomes like a grade 11 question. Because obviously, those are not on your unit circle. Those are not on your pie plate. So we have to, once again, find a reference angle, use our cast rule, say our answers. Is this question in degrees or radians? Radians. Okay, so I'm going to find my reference angle in radians. I've hit my mode button and switch back to radians. And I'm going to do cos inverse. I'm going to do this positive one first. Reference angle of 1.12. This one's positive, so it'll be in quadrant 1 and quadrant 4. Does it say to the nearest hundred? So quadrant 1 would be 1.12, and quadrant 4, go 2 pi minus my reference angle, 5.16. Find my reference angle for the other one too, so I go cos inverse of this answer. Now, when we do a reference angle, we always do it positive. So either option 1, I could just keep going back, doesn't take too long, and delete that negative and push enter. Or, quicker, you could just take that answer and go times -1. That would force it to be positive as well. My reference angle, 0.695. And this time, since cos is negative, we're looking in quadrant 2 and quadrant 3. So I like to use my store button, so I can store my reference angle as x. That way it's quick to find quadrant 2, pi minus x, and quick to find quadrant 3, pi plus x. 2.45 and 3.84. I'm going to make a little note. All of those answers were once around the circle in the positive direction. If we look at this question, however, what was the domain they asked us to solve for? It's like, oh man, why did you have to do this? Did I write it right? No, it has equals on both of them. Just for fun. So if we think about the domain they gave us, we're looking from 0 to pi in the positive direction, and 0 to negative pi in the negative direction. If I just label above here, this was quadrant 1, this was quadrant 4, this was quadrant 2, and this one was quadrant 3. Can you see quadrant 1 and quadrant 2 are going to be fine? Because we solved from 0 to 2 pi. So this one, we're going to write all of our answers down. The 1.12 and the 2.45 can stay. But we need to rewrite this one as a negative angle. And we need to rewrite this one as a negative angle. Just 1.12 is here, and 5.16 had the same reference angle in quadrant 4, does it make sense that if this one was 1.12, then in the negative direction, this is negative 1.12? Does that make sense? And in orange, in quadrant 2, if this was 2.45, and we want to find one with the same reference angle in the negative direction, can you see that this is going to be negative 2.45? It's exactly, because if this is my reference angle here and reference angle there, that's 2.45, this will be negative 2.4. And finally, for the general solution, if you look at the back, not the back, but if you look at the end of this section and the textbook's answer, they're going to write all 4 of them and use those negatives. Me personally, I like to use the ones I found between 0 and 2 pi. So that was 1.12, 2.45, and then I would use the 3.84 and the 5.16. To each of those, add 2k pi. And define k to be an integer. And you can do 12, 13, and 14, and I think 14 you can actually factor. So ours we couldn't factor. I think the ones in 14 we could factor.